Thank you for joining me with today's lesson. In this tutorial, we will determine what type of function pattern a set of data follows. We will use the calculator to calculate the best fit regression model, and we will use this best fit regression model to predict other data. So we are in a combination of a couple sections in our textbook 2.6 and 4.10, and we're talking about regression. This is going to be a heavily calculator-based lesson. Regression is a method for modeling a relationship between two sets of data. We are going to explore linear and quadratic, maybe cubic, some exponential regression using real-life data. What is this used for? We're going to be using this data to find a prediction equation. And of course, once we have a prediction equation, we can predict with it. And we can predict given the sets of data that we have. We have a bunch of steps on our calculator. Well, not a bunch of steps, but we have some important steps on our calculator. So I'd like to show you these buttons while we have the calculator. I've got my calculator here. If you could please get your calculator out now. If you do not have your calculator, just please pay attention if you're not able to get one for this tutorial. So here's our calculator. Of course, turn it on. When we're talking about statistics, most of the statistics stuff is going to be in the stat button. So if you can please find the stat button and push stat, and you'd be looking at this screen. The first thing we need to do is edit our lists. So it's already highlighted on number 1 here, so we could press enter. And we would plug in all of our data. The X's would be here in list 1, the Y's will be here in list 2. We'll do that in our first example. Once we have our data, what we need to do is figure out what type of what pattern it is. So we're going to go to y equals, and we're going to turn a stat plot on, a statistics plot. So when we push y equals, you can see that there are actually 3 plots on the y equals screen, plot 1, plot 2, and plot 3. If we want to turn any one of them on, we would press the up button, and then we can choose whichever plot we want. I, of course, just choose plot 1. To turn it on, we push enter, and then it'll be darkened. That means that it's on. Now be careful, if you don't have any data in your calculator and this plot is on, if you pushed graph, you're going to get an error. It's going to say, wait, where is your data? So understand that once you turn a plot on, it's looking to plot data. And if you don't have data, please turn this plot off so that you can graph any of your regular functions in the y equals. So we turn the plot on. Next, we are going to press zoom 9. Now, obviously, I can't do that right now because I don't have any data, but we're going to press zoom 9. Let me show you that. Here's the zoom button right up here in the top 5, and then number 9 says zoom stat. So if we have some data in our calculator, it would actually snap to the screen that fits all of that data nicely, and we'll be able to see the type of pattern that we have, if it's linear or quadratic or so on and so forth. So that's zoom stat. We'll do that on our first example. And then once we've seen which type of data pattern it follows, we're going to press the number 4 here, press the stat button again. And this time we're going to go over to the calculate menu, and there's a bunch of stuff that we can calculate. We've already calculated the one variable statistics. That helps us get the mean and the median and the quartiles and things like this. What we're going to be using are 4, 5, 6, and 0. Number 4 is the linear regression. Number 5 is the quadratic regression. Number 6 is the cubic regression. I guess we could use number 7 if we have a quartic regression. Number 9 is a natural log regression. Let me go down to 0 here. I guess that represents the 10. 0 is exponential regression. So just make sure once you see what pattern it is that you choose the correct regression to calculate. And we'll go ahead and use that. So let's look at our first example. Our first example says that we have the heights and weights of some students listed below in this table. We've given that the heights are going to be the x value and that the weights are going to be the y value. And we also have the dimensions that the units that they're measured in. Height is in inches and weight is in pounds. It says find the equation of the best fit model. Well, the first thing I need to figure out is what type of function do we have. So we need to enter this data into our lists. So we're going to pull up our calculator, and we're going to push stat and edit. List 1 again is for all the x's and list 2 is for all of the y's. Watch yourself when you're plugging stuff into the calculator. If you could pause the tutorial right now and enter those things into your calculator, I'm going to do the same thing. So pause now. Okay, so you should have all of the data into your calculator. I like to do a quick little check to make sure that I've entered the same amount of data in each of the lists. So these dotted lines should basically be one horizontal line. Double check all of your data if you have not already double checked that, but I'm pretty sure these are all correct. So we need to go into the y equals and make sure that our plot is on. One of these plots must be on. Mine is. And then I'm going to press zoom 9. Zoom 9 does my zoom stat. It's going to do a snapshot of the data in the good window that it fits. And obviously this looks like a line. This looks like a straight line. So that's our first answer. The type of function, this is a linear type of function. Hopefully that makes sense to you, that as your height increases, your weight is going to most likely increase as well. And it would be a linear pattern. So we're looking for the best fit model. Y equals what? So let's go to our calculator again. And now that we know that it's linear, we're going to go to stat and we're going to go calculate the linear regression. That is number 4. So you can go highlight the 4 and press enter, or you could just hit 4. That's going to give you a couple things on here. We can just press enter, enter, enter. We're using list 1 and list 2, and we're going to go ahead and calculate that and let the calculator do its work. And there you go. Now, most likely you're going to be given some long decimal. Let's go to 3 decimal places. 3 decimal places should be plenty. So this is y equals ax plus b, where a is 4.482 and b is negative 165.107. So my equation y equals 4.482x minus 165.107. And this is my prediction equation. And now I get to go and predict with it. It says, use this model to predict the weight of a student who is 55 inches tall. So we need to know, obviously we've been given the number 55. Is this an x value or is this a y value? Since we're talking about height, it must be x. So we're going to plug the 55 right in there for x. So y is going to be equal to 4.482 times 55 minus 165.107. So that means y is going to be, I'm going to use the approximate symbol, and let's plug this into the calculator. We'll plug this in. We'll do 4.482 times 55, subtracting 165.107. So there's my prediction, and it says about 81.403. 81.403. According to the data that we have, somebody who's about 55 inches tall is going to weigh about 81 pounds. Word problems should end in words, so I'm going to put, or at least my symbol for pounds, LBS. It then says use this model to predict the height of a student who weighs 136 pounds. This time I'm given this number, and that is a y value. So that's going to be plugged in for the y in my prediction equation. So 136 is going to equal 4.482 times x, x is what I'm going to be solving for, minus 165.107. This is a little bit trickier to solve. We have a couple more steps to do. They're not difficult steps. We're just solving for x. We'll add 165.107 to both sides. And I'm going to put this, we've got 4.482x is going to be equal to, if I add these two things together, it looks like I'm going to get 301.107. And then when I divide by my coefficient, 4.482, I will have x all by itself. So I will have, I'm just going to come off to the side here, x is approximately Pull up my calc. I've got 301.107, and I'm dividing that by my 4.482. Enter. 67.181. 67.181 inches tall. So we can use our prediction equation that we find from the calculator and predict for whichever variable we need. So there's an example of a linear. Let's move on to our next example. It says the following table shows the miles per gallon a certain car will have for various speeds. Now this time it did not tell us which one is X and which one is Y. So typically when they don't tell you what variable is what, the top of your table will be your X values and the bottom of your table will be your Y variable, your Y values. So our first question is the data best represented by linear, quadratic, cubic, or exponential models? So now we have some more data to go and fill in. If you could take your calculator, trying to pull it up, there it is, and plug those in. We'll go to stat and we'll go to edit. Actually, while we're here, since we already have data filled in there, we can either rewrite over this existing data or we can push the delete button to delete each individual piece, and it'll do that one at a time. If you want to clear an entire list at once, you would have to highlight the entire list and press clear, and then the entire list is gone. If you unfortunately push delete when you're highlighting a list, you will delete that list from the calculator, and that is no good. So if you need to call back a list or get the list back, if you notice in the stat menu, there is a setup editor. A setup editor that will help you, and that's number 5. That will get your list back for you. So if I run that setup editor program and then go back to stat and edit, you can see that list 2 is now back. Okay, so take some time and plug these values into the calculator. Press pause and I'll do the same thing. Okay, so here is our data. Oops. Here is our data. I've plugged mine in and I've double checked to make sure that it's all there and that I have equal amounts. So there we go. Now we're interested to know what type of pattern it is. So I'm going to go to the y equals. I guess I don't need to do that. I already know my plot is on. I'm going to press zoom 9 and it's going to snap to this data. Oh, interesting. Okay, this is definitely not linear. It looks like it's following some sort of quadratic. Let's go to stat and calculate. And this time, like I said, I think that it's a quadratic regression. I'm going to go down to number 5. So you can highlight that or you can just push the number 5 and there's our quadratic. When I calculate this, it's going to calculate what it thinks is our quadratic relationship, and that's y equals ax squared plus bx plus c. So it's going to give me a, b, and c. Again, it was quadratic. And our prediction equation, y equals, I'm going to go to 3 decimal places, so negative 0.019 x squared plus 2.113x minus 29.364. There's our prediction equation. I knew that a, the leading term, had to be negative because this was ultimately an upside down parabola, an upside down quadratic. And now let's use this to predict. It says use the model to determine what the gas mileage, miles per gallon, would be if you're driving 85 miles per hour. Again, we have to figure out what variable 85 miles per hour is. 85 miles per hour would be the x. So I'm going to plug the 85 in where I see x there and there in our prediction equation. So y is going to equal negative 0.019 times 85 squared plus 2.113 times 85 minus 29.364. If I plug all this right into the calculator, I've got negative 0.019 times 85 squared plus 2.113 times 85 minus 29.364. Let me do a quick double check on that. That looks good. I'm going to press enter, and y is approximately 12.966. Y is approximately 12.966, and that is miles per gallon. Yet another reason not to speed. Your cars are optimum when they're going about the speed limit, at least highway speeds. You can see that you're getting the best gas mileage right here. When you start to go over and over the speed limit, your gas mileage starts going down, like that quadratic pattern. And if you're really speeding 85 miles an hour, I don't think that's legal anywhere, at least not in the United States, you're getting terrible gas mileage. So you're wasting money if you're trying to get there early. Okay, let's look at our final problem. New set of data. It says the table below shows the heating temperatures for a pot of tea after several minutes. So after 0 minutes, actually you haven't even started heating the tea up. It's about room temperature, I guess, 70 degrees. And then after 3 minutes, 6 minutes, 9 minutes, and there and so on and so forth, you can see that you're heating it up and it's getting hotter and hotter and hotter and very hot over there. So let's plug this into our calculator. I'm going to go calculator and push the stat, and I'm going to edit my lists. Since I already have a bunch of data in there, I'm going to highlight list 1 and press clear and then down. They're all gone. I'm going to highlight list 2, press clear and then down, and now all that data is gone. Why don't you pause right now and enter this data into your calculator. Okay, so here is our data. Again, I've entered it all in and I've double checked. So now I need to see what type of data pattern this is. I turned my plot on and I'm pressing zoom 9. And I can see that this is going upward like this. It kind of looks like an exponential regression. And in fact, if you notice in the problem, it says this is following an exponential regression. So I'm definitely giving it away that it's exponential. I need to find the best fit model. So since I know that it's exponential, when I go back to stat and go over to calculate, I'm actually gonna press up. I think that it's faster. Oh, maybe not. To get to the 0. Exponential regression is right there for 0. I'm gonna press enter. And it's telling me from list 1 to list 2, which is where I put my data. That's great, and I'll calculate it. This looks pretty good. The exponential regression gives y equals a times b, the base, to the x power. So they give me the a value, and they give me the b value. So let's write our prediction equation down. This is y equals a was 63.367, if I correctly round. B, the base, was 1.037, and that's being raised to the x power. So that's what I need, and now I get to go and predict with it. It says, what would the temperature of the pot of tea reach after 30 minutes? Minutes is our x value, so the 30 minutes is going to go right in here for our x, for our exponent, actually. So y is going to equal 63.367 times 1.037 raised to the 30th power. And that's going to be approximately, let's plug that into the calculator, 63.367 times 1.037, and then I'll push my caret to raise to a power to the 30th power. Push enter. And it says about a 188.463. 188.463. Let's put some units in here, and since we're talking degrees Fahrenheit, that is a hot pot of tea. My last problem, going backwards. At what time would the temperature of the pot of tea reach 160 degrees? So this is our y value. 160 degrees is going to go right in there, and let's plug that in. We've got 160 degrees equals the 63.367 and then the 1.037 to the x power. This is a little bit trickier to solve. It's an exponential equation. We're trying to get this x value. which means that we need to eventually get this base out of here. But even before that, we have to get rid of this coefficient. Coefficients are just being multiplied to something, so I'm going to divide them first. I'm going to divide this 63.367 out of here. And I don't know what that is. I'll have my calculator deal with that. But I'm going to have 1.037 to the x power is equal to, let's go ahead and calculate what that is. Slide this over. We've got 160, and we're dividing by 63.367. That's 2.525. So we've got this equal to 2.525. 2.525. So now we're looking at this equation and we're trying to solve this. Obviously, this is not going to be on our power sheet because I don't have the base 1.037 to the x there. We haven't learned how to solve this using logarithms, at least taking the common log of both sides. But what we have done is we've learned how to transform this, how to rewrite this exponential equation into a logarithmic. We know that this is equivalent to the log base 1.037 of that number 2.525, and that would equal the exponent of x. So rewriting this exponential equation into this logarithmic equation, we can solve for x. All we need to do is be able to plug this into our calculator, this log base 1.037 of 2.525, and we've got that function on this calculator. So when I plug this in, I can go to math, and I push up twice, up, up, and I have my log base. Pushing that gives us a little spot for the base and a little spot for our number. So there's our 1.037, and I'll push the arrow to get into the number spot. This is 2.525, and that's all that I need. Push enter, and we have x is approximately 25.494. X is approximately 25.494, and we're talking about minutes. It's about 25.5 minutes. So that's a good equation to solve. Okay, so that's it with our calculator and our regression. We'll practice these calculator steps. If you did not have a calculator while watching this tutorial, then we'll definitely make sure that you practice these functions when we get into class. Thanks a lot for watching, and I'll see you then. Bye-bye.